Greetings, TRS-80 friends. This is a follow-on video to my previous video about designing a replacement for the LCDs in these TRS-80 PC-1 pocket computers, also known as the Sharp 1211. And I received samples. So I have three of these machines. This one is the Sharp version, and these two are the TRS-80s. And I've replaced the LCDs in two of these. So this one works just fine. You can just put characters in there, and they all look great. The O actually has a little dot in order to differentiate it from the numeral 0, which doesn't have the dot. But, you know, anyway, it works just fine. So that's great. I replaced it in this one, which is a TRS-80 PC-1, and unfortunately, it's not so happy. So sometimes what you have to do is hold down the reset button to get, like, I guess all the LCD drivers to clear. But this one, unfortunately, is having a lot of problems. And I went in there and I replaced the LCD. I took the bezel out and I moved the LCD around and I replaced it. This is my third try and I'm still not getting any joy here. So I'm not really sure what's going on with that one. What I am going to do is I'm going to take this final one, which is actually a working model. The LCD is a little bit damaged up here, but you know, all the characters work. And what I'm going to do is I'm going to replace this to see if, you know, maybe there is just some sort of a problem going on with this. Maybe the LCD in particular is bad. Maybe, I don't know, the contacts are different. I'm really not sure. So I'm just going to replace the LCD on this one and see what happens. The LCD has been soaking in acetone for overnight, actually about 16 or 18 hours or so. So now the acetone should have loosened up all of the adhesive. So now we can probably just press the LCD out of the bezel. And the bezel is really the only thing we need. Now we have to be a little bit careful here, because if you sort of detect that the LCD is not actually moving, then pressing harder may risk simply breaking the glass, which makes your task a little harder and can possibly injure you. So I'm just going to take a little prying tool. There we go. So that's it. Now really all we want is the bezel. The rest of the LCD we can do what we want with. It's damaged, so you can just throw it away or take it apart or whatever. I'm just going to set it aside for now. Now in the bezel, there are these strips of adhesive that were placed during manufacture. Now the interesting thing is, during manufacture, those strips of adhesive would have to be put down first, and then the LCD put down on top of it, which means that they had to know exactly where to place the LCD in order to get it to align with the pads. So what I think they did, so first of all, if you look at the LCD, there's a little bump on one side and there's no bump on the other. And when I looked at the LCD before I put it in acetone, basically the non-bump end was pushed all the way up against the edge of the bezel. The edge of the bezel that they pushed it up against had this little hole over here and sort of this little window cut out over here. And it's possible that what they did was they would place the LCD in there and look at the little window and look at the pads on the LCD. And they would line up some of the pads with the window. And then they would know that, I guess, it was a good bezel. So in order to place the new LCD in here, what I would do is pretty much do the same thing, because when I manufactured the new LCDs, I had them put the bump on the same side. It's the same size. The pads are in the same place relative to the edges. So in theory, you should just be able to jam one of the edges of the LCD up against the bezel, and it should work. So let's remove the adhesive strip, since we don't actually need that. I'm just going to scrape it off. And I suppose if a little of it remains, that's okay. All right, so that's one strip off. Let's get the other strip off. Okay, so I've cleaned the adhesive off the bezel as best as I could. And now what I'm going to do is I'm just going to clean the bezel with some IPA, especially where the adhesive was, and there's a little piece left over. And this will just help clean off any residue that remained and also any dirt that's in there. Okay, so here is a new LCD. And the LCDs come with, now I can take my gloves off because I don't want to get any adhesive residue on the new LCD. So the new LCD comes with a little plastic sheet on the top that you do need to remove. That was to prevent any scratches. So now the new LCD has a bump on one side and no bump on the other. So what we're going to do is we're simply going to we can place the edge up against the edge of the bezel right over here. But what I like to do is I like to wedge a little piece of paper, a few pieces of paper, up against the other edge so that the LCD doesn't move back and forth when I'm trying to place it in its proper position. So to do that, I'm just going to take a piece of paper and I'm going to rip off just a little piece. And what I like to do is I like to fold it over once, twice. That's probably good enough. This is probably a little too big. And then I'm going to, let's see, do I have a razor blade here? I think I do. So I'm just going to take a razor blade and cut off a bit of it. And that's really all I need. Now this is just standard laser paper. I think that means that it's about 4/1000ths of an inch thick. That means that this is going to be 0.016 inches, if anybody really cares. So I'm just going to place it up against the edge like that. And then I'm going to take the bump and push it up against the piece of paper. And then the LCD should just fit right in. Now we can see that it's not really moving back and forth, which is fine. Now the other thing that we can also do, and I've put this in the wrong way, so let's put this in the right way. So the idea is that the edge without the bump goes up against the edge where the little hole is and the little window is. So let's do that again. Okay. So one of the things that you can do is maybe look at this window and see if the pads are in the correct position. Now, when I looked at the pads on the original LCD and also on the replacement that was successful, and also the replacement that wasn't successful, so go figure, here's the window, and here is one of the pads. Here is another pad and the pad in the center, and then basically nothing here. So this is sort of like the edge of the LCD over here. So what you want is this window to sort of be centered on this second pad up here. So the only way that you're going to be able to tell is sort of rotate it until the light hits the LCD just right so that you can see the pads. So I'm going to do that now. And it looks correct to me. And of course it should be, because again, the LCD was constructed so that that pad sits at a particular distance from the edge of the LCD, which means that if you push the LCD up against the edge, then the pad should end up in the right place. So there we go. Now the next thing that I'm going to do is I'm going to take a fresh Q-tip. So the next thing that I'm going to do is I'm going to take a fresh cotton bud, and I'm going to clean up the surface of the pads with IPA. And this is important because you don't really want any dust or hairs to get in the way of the pads. Now, the problem with just soaking the cotton bud with IPA is that the alcohol will probably get underneath the LCD, between the LCD and the bezels, so I just like to sort of get rid of some of the excess. And then we're not going to press, we're just going to lightly go up against the pads. That's good enough. All we're really trying to do is pick up any small pieces of dust. I'm going to use the other end to just dry it off. And again, if anything actually got under the LCD and the bezel, it should evaporate. So as I turn this over, I did see a small piece of adhesive here and another small piece here that I really want to remove. Okay, since I can't get that piece out, I'm just going to remove the LCD. Careful not to touch my nice clean surface. And remove the adhesive from the other side. Okay. Now I'll put it back again. I need to put the piece of paper back in. Push it up against the edge with the LCD. There. That's better. That looks much nicer. Okay, so we've got clean pads. Now the next thing that I'm going to do is I'm not going to touch the elastomeric strip with my hands because that'll just get oil on it. So I'm using some tweezers. And I've got a dust-free towel. So this is a Kim wipe. And I'm going to clean the strip with IPA. And again, the reason is that you just want to get any dust, hair, and oil off of the surface. And you don't want to touch it with your hands. So once you've done that, once you've got the sort of worm in the tweezers, you can just lay it down. Just lay it down on the LCD like that. And it's going to land in one of two ways. There's sort of like the spine of the worm, which is this sort of black line that you might see over here. If it lands on its side, then you won't see that black line. So the black line really are the conductors, and they go up and down. So what you want to do is you want to place the strip onto one side of the pads. And you just want to put it in so that it doesn't overlap the edges of the bezel. Now, it might actually wiggle a little bit. That's just fine because the pads cover the entire area. The elastomeric strip is sticky when it's clean, which is great. It means it's not going to move. So, you know, just tap it down and there you go. It's good enough. If the wiggling really sort of bothers you, you can probably, you know, maybe move it up against the edge of the LCD over here, or maybe against the edge of the bezel. It's probably better to put it up against the edge of the LCD. Now we're just going to do the same thing with the other side. Now the nice thing about the elastomeric strips that came with the calculator or computer is that the conductors in the strip are very small. Some elastomeric strips are built so that the conductor is on the same order of the size of the pad, which makes it difficult to align. These have very fine conductors, which means that you don't have to worry about aligning the strip properly, which is good. Okay, that one ended up on its side, so I'm just going to have to pick it up. Okay, that's it. Now, since I'm touching that elastomeric strip, you probably, before you do this, you probably want to clean your tweezers with IPA so that there's nothing on it that can get on the conductors. Okay, so it looks pretty good. I'm not really happy with how far off the strip is from the LCD itself. Again, it shouldn't really matter because the pads cover the entire space between this part of the LCD and the bezel. That's because when I remanufactured these LCDs, I used the exact size of the original. But okay. Yeah, I'm pretty satisfied with that. Again, it's not too critical. I just like to see it a little more straight. Okay, so the next thing that we're going to do is place the new LCD with bezel on the printed circuit board. So first thing that I'm going to do is wipe off the pads with IPA so that they too are nice and clean. And now is probably a good time to inspect the pads to make sure that there aren't, so that none of them are covered in any sort of oxidation or any other kind of damage that might get in the way of making a nice electrical contact. Okay. So the LCD is, fairly tightly in here, but I wouldn't want to actually turn this upside down. So what we do is with the battery compartment over here on the right side and the edge of the LCD here on the left side, we take the side that has the window, and this is going to go on the printed circuit board like this. So what I'm going to do is I'm just going to fit these 4 tabs at the bottom into the 4 holes in the printed circuit board. So that lines that up. And then I'm just going to rotate it so that we're now on the printed circuit board. And that didn't work out too well. So I'm going to reset. And unfortunately, we got the elastomeric strip sort of stayed behind. So I'm going to put it back. And ordinarily, when the strip moves around or falls off or ends up someplace that you don't want it to be, you want to clean it again. This time, the strip didn't touch anything. Okay. So we'll try this again. And one of the other crucial bits is to get this side tab into its hole as well. we go. All right. So now, while I'm pressing the bezel and LCD up against the printed circuit board, I'm going to place it face down on the table and then carefully open this up. Carefully, because these wires could possibly break this connector between the two LCDs, and you don't want that. So now it's just a question of pressing down on the LCD to make sure that there is firm contact between the pads on the printed circuit board and the elastomeric strip. And then, while we're pressing down, we're going to bend over these tabs. So what I like to do is I like to start at one end, keeping pressure. And I'm just going to take one of the tabs and bend it over just a little bit, just to get it started. And then I'm going to use something that I can push and just bend this tab over just like that. And now I'm going to do the same on the side tab. Okay, and there should be another tab here. So I'm going to bend over. Okay, and that secures this side. And now, keeping pressure, I'm just going to move over to the next tabs. The next pair of tabs here. And you want to press down as you're bending the tabs over. Okay. Now, one of the interesting things is that as you're bending the tabs over, you have to remember that you might not be successful in putting the LCD in just the right place. And if that happens, then you're going to have to bend the tabs out again. So when you bend these tabs, don't be fast, because if you're going to bend them fast, then you might fatigue the metal and cause it to break. And then you don't have a bezel, and you're kind of screwed. So I could totally be wrong with the physics of that. You know, that maybe actually bending a tab, the velocity that you bend the tab at doesn't actually matter in terms of fatigue. So I could be wrong, but it sounds nice. So when you get to the tabs around this section, these are the protective diodes for the battery. You want to be a little bit careful. The side tab goes very close to this sort of multi-junction solder joint. So I'm just going to turn this, and then I'm not going to rush it. I'm just going to make sure that I'm placed properly and then bend it over slowly and with a controlled motion. And the most difficult tab is the one over here because these diodes are sort of in the way. So I'm going to gently bend the diodes up and out of the way. And then, let's see, I think I'll do this from this side. Bend the tab over a little bit. Now I'll move this to this side and bend that tab over. Okay, so now the LCD is secured. So now we have this bottom part, and hopefully when you took out the printed circuit board, you did it very slowly and very carefully, because otherwise all the keys are going to go all over the place. So then you're going to have to look up an image on the internet and place all the keys in their correct positions. I don't have to do that here. So I do see a little speck of something on one of these contacts, which I want to remove. Okay. And I guess, you know, if you really want to, you can remove the keyboard rubber with its contacts and then clean the contacts. I haven't really found that that's necessary. So, in order to put this back, so first of all, we've got the polarizer that was left over from the old LCD. Now, the new LCD has the polarizer integral to it. So, we're going to need to remove this polarizer because we've already got a polarizer, and this one may, in fact, be at the wrong angle. So what I'm going to do is I'm going to lift it up, carefully, because there's a strip of adhesive right over here, which is holding down that whole set of structures. So I'm just going to bend this, and I don't care if I damage it, because again, I'm not going to use it again. Now underneath it, there's this sort of metal surround. Try not to bend that. So what I'm going to do is I'm going to go underneath the adhesive and hold down the metal so that I can peel off the polarizer. And there we go. There's your polarizer. And you can see that it's polarized because if I have another polarizer here, so you can actually see that it's actually polarized. So, okay. And we can leave the adhesive there. It doesn't really matter. It doesn't do anything. It actually serves a purpose to hold down this metal surround. This kind of, I guess it's a little decorative maybe. Anyway, so let's put the printed circuit board back. Now, one interesting feature, which we'll take a look at, is this potentiometer right here. This trimmer is the contrast adjustment. So this trimmer is the contrast adjustment, and it is going to alter the voltage that goes to the LCD. The voltage that goes to the LCD basically changes the level of the signals that are sent to the LCD. So the stronger those signals, or the higher the voltage, the more it's going to turn on these pixels. And if it's too high, all of the pixels are going to be on, even if they shouldn't be. So now the problem is that this LCD is a little more sensitive than the old LCD. So unfortunately, we cannot keep the same setting. Also, unfortunately, they used some sort of a paint or glue or something in order to fix the position of this trimmer potentiometer, which means that you can't simply turn this potentiometer and change the contrast, which is unfortunate. Now, because this LCD is relatively sensitive, I've found that you can actually desolder this potentiometer and replace it with a fixed resistor. I use 240K. This potentiometer, according to the schematics, is 250K. I've actually measured some of them as high as 300K. So what we're going to do is we're going to not use the contrast adjustment. We're not going to replace it, and we're just going to replace the printed circuit board, and then you can see what happens. So what we do is we slide it underneath, and then we just press it down like that. Now what I like to do is I like to place these two screws in first, then the other screws, then the battery terminals. So let's just fast forward through that. So now that all the screws are in place, we need to replace the battery terminals. Now, these are also quite fragile. They may break off, in which case you're going to have to solder them back in. So to place the positive terminal, what I like to do is hold it in my fingers like this and push up against the wall, just like that, with a set of tweezers, and then push it down. And if you maneuver it properly, you'll get it to go into its slot, which is sometimes quite difficult, but it can be done with patience. Okay. So bad luck, I didn't have the camera on and recording when I tried to turn this on. What happened was I turned it on and all of the pixels and indicators were on, of course, because the contrast adjustment was incorrect, with the exception of a single line of pixels. So as you'll see, I did manage to fix that. It was due to a broken trace. The other thing that I didn't manage to capture is how to fix the contrast. So to fix the contrast, you remove the top two screws, open up the printed circuit board carefully until you see the contrast adjustment. Now, if I zoom in a little bit, and unfortunately I can't zoom in too much with this camera because it doesn't really have a macro feature, the potentiometer has this semicircular area, which is the resistance, and then there's a metal piece in the middle, which is the wiper. So what I basically did was I took a pair of tweezers and then a pair of needle nose pliers, and I pulled on that wiper and basically bent it and removed it. So now this potentiometer is not actually a potentiometer, but actually a fixed resistor. And the top resistance of this trimmer is enough to get the contrast correct. So once you've removed all traces of that wiper, you can just close it up and turn it on, and then it works properly because the voltage is now not too high. Now, you can sort of see that some of the pixels are on faintly. That's fine. So. Now, as I was removing these tabs, I did notice that there was a scratch here, and I checked it with my multimeter, and indeed one of the traces is actually not conducting. Okay, so I repaired that trace with a tiny bit of wire. This was my fault because when I was originally removing this tab, my screwdriver slipped, so be careful when you do this. All right, let's put this back together and check it out. Okay, let's have a look. I'll turn it on. And it seems okay. Now, what I've noticed sometimes, and in fact that line is showing up now. So what I've noticed sometimes is that you might get, like lines across the screen. Some of these indicators may be lit more than just 1, 2, and that one. In which case, just hold down the reset button while it's on and try again. And should just reset. I suspect that's because there are a bunch of LCD chips on here that all need to be synchronized, so maybe that's something. But in any case, if you see like garbled characters on the screen, just reset it and try again. If it still doesn't work after that, then maybe there is something wrong with the machine or with the LCD. I kind of doubt it's the LCD because so far I've gotten things working on 2 of my devices. So here's the one that just doesn't work. And you can see that multiple indicators are lighting up. The characters are garbled. Again, I'm not really sure what's going on. It looks a little bit suspicious in the way it actually draws the characters. It's sort of like it's drawing it from the bottom up. So I suspect that there's something actually wrong with the circuitry on this and that there's nothing actually wrong with the LCD. So I might take a look at this later. But we have now a working machine with a working LCD. So I can use the ease and we can see that there are no pixels missing. Everything works great. The mode works perfectly. I can go into program mode. I can type in a program. I can go to run mode and I can run that. So that's it. That's how I went ahead and manufactured new LCDs for this old retro computer. Now, the samples that I got I think 12 samples or so. So I used up 3 for this. I've got several left. 3, 6, I've got 9 of these left. And these are considered samples. In other words, the manufacturer made them and sent them to me, and this is basically a large part of the startup cost. This basically cost me $350 to get samples. The idea is that they do this for you so that you can evaluate the samples that come back and make sure that they work. And if they don't, then you send them the changes and you go through a whole other set of samples, which means another $350. But these work fine. Again, they send you the samples with the intention that you're going to order a larger amount after you evaluate them, which I am going to do. The minimum amount that I managed to negotiate was 200 of these for another $500. So that's a total cost of $2.50. So of course, when you add everything up, including the non-recurring costs, which is the cost of the samples, and then the shipping, and then there's and then anything else that I want to add to this, for example, if I wanted to ship this to somebody else, I have to account for the cost of that shipping. But not only that, but also the cost of the box and the packing. In addition, what I'm planning on doing is I'm going to sell these on Crowd Supply, which is a crowdsourcing platform, kind of like Kickstarter, kind of like Indiegogo, except they actually want to see a business plan. So they want to make sure that your project actually makes sense in terms of costs. So I costed everything out. You have to account for things like fees that Crowd Supply charges you, fees that the credit card companies will charge you or that PayPal will charge, all that stuff. So when I did the numbers, I determined that I would have to sell these for something between $15 and $20 a piece, which basically covers everything. In addition, if you've ever watched EEV blogs, posts on how to make a project actually profitable, you want to go for 2.5 times your cost, because if you do that, that means that you can finance the next project. And there is going to be a next project. This is the PC-1. There's also a PC-2, and the LCDs there suffer from the same problem. The LCDs are different, so I'm going to have to go through remanufacturing that. So in order to finance that, I have to charge 2.5 times the cost, which again comes out to $15 or $20 a piece. You know, which is a far cry from the $2.50 a piece that these actually cost me. But again, you have to take into account all of the fees. So there you go. I hope you enjoyed that. I may actually provide a service where you can send me your PC-1 and I can repair it with a new LCD. Again, that is not guaranteed because the machine itself may be damaged and I can't repair that. Or it just might not work for one reason or other. So I just can't guarantee that. But I might offer that service. But first I'm going to get Crowd Supply set up. I've already applied to get these crowdsourced. It's taking them a little while because they've been very successful and now they're kind of overloaded and they're looking for more employees. So it may be a while, but that's the plan. So thanks for watching. I hope you enjoyed this, and I really enjoyed going through the whole design process of the LCDs, getting them back. Well, first of all, looking for manufacturers who are willing to go as low as 200 pieces. Some of them were more like 1,000 pieces or more. Getting them back, testing them. I was not able to create a tester for the LCDs, a testing jig, which I still am going to have to do, because unfortunately the chip that I chose, for whatever reason, required the LCD voltage to be higher than the logical supply voltage. And the supply voltage that I was using was 5 volts. And these LCDs require something like, 2.5 to 3.5 volts, which is not great. So I'm going to actually have to design my own LCD driver, which is unfortunate, and it's going to take time, and it's going to take expense. But that's what I'm going to have to do if I get 200 of these and I want to make sure that I have good quality control. So again, I hope you enjoyed that video, and don't forget to subscribe. See ya.